Hi, I'm Sayan, and today I'm talk about the memory, which one we learned in last week. Memory is divided into two kinds of memory. First one is RAM, and second one is ROM. RAM is random access memory, and it means we can write the data in the memory in any location and in any sequence, and we can also read the data in any sequence. And RAM is divided in two kinds of memory. First one is SRAM and second one is DRAM. And RAM is volatile memory, so when we turn off the device, then the data which was routed in memory, then the data is gone. And ROM is read-only memory. It means we can do the just read operation through this memory, and this is non-volatile, so it is irrelevant of turn on or turn off the device. The data is maintained. And next one is memory architecture. There is storage array and low decoder and sense amplifiers and column decoders. The storage array is main part of the memory, and it is called as cell array transistor. And this needs the high degree of integration, so we usually use the high K material to make this. And other part is called as peripheral transistor because it is located in the round of the storage array, and this peripheral transistor needs the high safety, so it usually uses the silicon dioxide. And next one is SRAM. SRAM is static random access memory. It means the data is not changed along the time. And this is the structure of SRAM. There is total 6 transistors in one unit cell. The middle of 4 transistors is acted as latch, and side of 2 transistors are act as a switch. So we put the signal into the word line, and we do the signal addressing in 2 switch, and then the SRAM is turned on, and we put the signal also into bit line, and then we can write the data into the memory. Let's say the case of put the signal 1. When we put the signal into the bit line, the signal 1, and then first we put the signal into the word line, then the M5 and M6 is turned on, and the SRAM is turned on. And we put the signal into the bit line, we write the data 1 into the bit line, then the M1 is turned on and M2 is turned off. And then this side is bit line bar. It means the opposite of bit line. So it means we put the signal 0 into the bit line bar, and then because of this signal, then the M4 is turned on and M3 is turned off. It is the case of put the signal 1. And the strength of SRAM is this device is fast, and the weakness is the degree of integration is low because of there are many transistors in one unit cell. And next one is DRAM. DRAM is dynamic random access memory. It means the data is changed along the time. this one is structure of DRAM. There is one transistor and one capacitor in one unit cell. When we do write the data into the memory, then we put the signal into the word line and turn on the device, and we also put the signal into the bit line. Then we charge the capacitor, and then we can write the data into the memory. And when we do the read the data, also we put the signal into the word line and turn on the device, and from that signal, from the word line signal, the small quantity of charge is come out through the bit line. Then through the sense amplifier, the charge is amplified, and we can measure that charge, and then we can read the data. The strength of DRAM is the degree of integration is high, and the weakness is the device is slow and power dissipation is high. Because the DRAM is the charging and discharging, so the device is going to be slow, and also power dissipation is high. And because of that, it needs the refreshing. So when we when we make the power dissipation going to be decrease, then we have to increase the RC time delay, and for that we have to increase the capacitor C, and for that we'll use the high K, that is high epsilon material. Then we can increase the RC time delay, and then the repeat of refreshing is going decrease. Then the data, the accuracy of data is increased. Thank you.